This is Homeschool 101, a collaboration between ABS Television and the Ministry of Education. Stay attentive and attempt all activities. And now, today's lesson.
Hello everyone, and welcome to another class in Homeschooling 101, another integrated mathematics class. For today's class, we're moving on to Module 2, which is statistics, and we will look at the topic for today is Introduction to Probability. At the end of today's class, you should be able to state some applications of probability in everyday life, define probability, distinguish among the terms experiment, outcome, event, and sample space, distinguish among the methods of assigning probability, apply basic rules of probability, and explain the meaning of calculated probability values. So, what are some applications of probability to everyday life? We use probability in weather forecasting. For example, you may hear the weather reporter states that there's a 60% chance of rain. That is probability being used. Probability is used in sport to determine batting average, for example, in cricket. In politics, where analysts use the probability to predict the outcome of the election's result. Probability is also used in insurance when determining the coverage based on risk assessment. And in terms of playing games, probability is also used. For example, more practical, we would think about probability. Many times we would hear we have like a lucky dip, or many companies may offer, maybe offering a prize, say you will win this or you will win that. Probability being selected or your chance of winning a prize, probability is being applied there. Now, what exactly is probability? The probability of an event is the measure of how likely the event is to occur. It is a study of chance occurrences. Other terms that we may use for probability include likelihood, chance, percentage, proportion. And the probability of an event is normally a number. It's always a number between 0 and 1. And because we can sometimes refer to probability as percentages, the probability can be stated as a percent. The probability scale. Now, the probability of an event E occurring, denoted by P of E, is a number as indicated before, between 0 and 1. And if we look along this scale, if we have a value of 0, a probability of 0, it means that the event is impossible. If we have a probability of 1, it means the event is certain to occur. And along the probability scale, if we have a probability of 0.5, it means there is an even chance of the event occurring. So the range, the probability will always be a positive number between 0 and 1. We will go through some definitions of terms that you will see being used as we go through. So the first term is experiment. And when we think about an experiment, a statistical experiment is any procedure that can be infinitely repeated and has a well-defined set of possible outcomes. Although we're able to state all the possible outcomes, we're not able to state what a specific outcome would be. For example, if we toss a die and we know the options or the outcomes would be 1, 2, 3, 4, 5, or 6, if we toss a die once, I'm not able to state what the value is going to be. I can state the list of values or the possible outcomes, but not specifically what that value would be when I toss a die once. And when we think of an outcome is a possible result of an experiment. The other definition we will look at is the sample space. And the sample space, denoted by S, is the set of all the possible outcomes of an experiment. So if we look here, we would see the sample space for a pair of dice. Then this is what we would have. These are all the possible outcomes, and the terms here would represent the sum of the terms on both die. So these would be all the possible outcomes. An event, we refer to event as any possible outcome of an experiment. And the probability of an event is denoted by P of E, and this is the likelihood that the event will occur. For example, the event may be defined as obtaining 2 heads from tossing a coin twice. And in a simple event, it consists of a single outcome. We would then focus on the methods of assigning probability. Now, there are three methods of assigning probability. The first is the experimental or the relative frequency method. The second is the theoretical or the classical or the sample space method. And the third would be the subjective method. Now, in the experimental or the relative frequency method, in this case, a statistical experiment is performed n times and a particular event A occurs. Then we say the probability of A occurring is equal to F divided by n, where F refers to the frequency or the amount of times that particular event occurs. And it says as n approaches infinity, meaning that the experiment is carried out numerous times. The theoretical or classical or sample space method. The sample space, as we mentioned before, refers to all the possible outcomes. So in the theoretical or the classical or sample space method, essentially what we look at is the possible outcomes, the events occurring divided by the total sample space. So the probability of an event is given by P of E is equal to NE, which is the number of outcomes of the event, divided by NS, which is the sample space. The final method is the subjective method. And in this method, the probability is assigned based on personal assessment of the circumstances. It is based on one's opinions, one's feelings, one's hope. It is the least scientific of the methods, and there are no formal calculations involved in doing the subjective method, in using the subjective method of evaluating probabilities. So I have an activity here, and it states which of the following is another name for the sample space method for assigning probabilities. So the options: theoretical method, experimental method, relative frequency method, or the subjective method. Right? So we'll go through the solution. So the other name or another name for the sample space method, the correct option is A, which is the theoretical method. We will now define the various types of events. So the first event that we will have is a complementary event. So it states, let E be any event defined on a sample space S, then the complement of E, denoted E prime, is the event that occurs when E does not occur. So the probability of the sample space is equal to 1. Thus, the probability of the complement event occurring is equal to 1 minus the probability of the event occurring. And the probability of the event occurring is equal to 1 minus the probability of the complement. So essentially, whenever we're dealing with probabilities, because the probabilities range from 0 to 1, the sum of, for a given sample space, the sum of the probabilities is always equal to 1. Therefore, if we want to find the complement, it is always 1 minus the probability of the event occurring. The second type of event that we will look at is what is called the mutually exclusive events. And for mutually exclusive events, they can't occur at the same time. So it says two events A and B are said to be mutually exclusive if they cannot occur at the same time. And if we look at the notation, A intersects B, meaning both occurring, that would be an empty set or a null set because they can't occur at the same time. And so the probability of both events occurring would be equal to 0, meaning it is impossible. The third event that we will look at is what is referred to as mutually exhaustive events. Now, two events are said to be mutually exhaustive if their union represents the sample space. So when we look at it, when we take both events, all the events that are occurring, everything is equal to the sample space. The sum of these two events, or the total of these two events, represents the sample space. The fourth type of event that we will look at are independent events. And two events are independent if one does not affect the other. So the probability of one occurring does not affect the probability of the other occurring. So in this case, the probability of A intersect B for independent events is equal to the probability of A times the probability of B. The fifth event that we will look at are dependent events. And if we look at the definition of independent events, independent meaning one does not affect the other. In the case when they are dependent, it therefore means that the occurrence of one will affect the occurrence of the other. So a second activity, so it says two events A and B are said to be, fill in the blanks, if they cannot occur at the same time. Are they complementary? Are they mutually exclusive, mutually exhaustive, or are they independent? Right. Now, if you indicated that they were mutually exclusive, you are indeed correct. So they are mutually exclusive if they can't or cannot occur at the same time. We will then go through some rules of probabilities. So the first rule is what we refer to as the general rule. And it states that the probability of A or B, and make note of the symbol, we use the union symbol or the union sign to represent or. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A intersect B. For mutually exclusive events, if they are mutually exclusive, as indicated, they cannot occur at the same time, hence the intersection would be equal to 0. So the probability of A intersect B would be equal to 0, and the probability of A union B would be equal to the probability of A plus the probability of B. And this we refer to as the addition rule. The third rule states that for complementary events, the probability of A is equal to 1 minus the probability of A complement. Or the probability of A complement is equal to 1 minus the probability of A. Continuing, for exhaustive events, the probability of A union B is equal to 1, because remember we said the union of both is equal to the sample space, and if the total probability must be equal to 1, then the probability of A union B is equal to 1. And to find the probability of A plus the probability of B, this is equal to 1 plus the probability of A intersect B using the general rule. And usually when we look at all the other rules, from the general rule, we're simply applying the general rule to find what the other rules are for the various events. Now, if the events for mutually exclusive and exhaustive events, then the probability of A intersect B is equal to 0, and the probability of A plus the probability of B is equal to 1. For independent events, remember we said independent, one does not affect the other, so the probability of A intersects B is equal to the probability of A times the probability of B. And the final rule that we will look at is conditional probability. And for conditional probability, the probability of A intersects B, or A and B, is equal to the probability of A given B times the probability of B, or which is equal to the probability of B given A times the probability of A. And to find the probability of A given B, this is equal to the probability of A and B divided by the probability of B. So let us go more in depth into conditional probabilities. Now it says, let A and B be any two events. Then the probability that A will occur, given that B has occurred, is denoted by A given B. The probability of A slash B, and that is read A given B. And this is called the conditional probability, that A will occur given that B occurs. So when we're dealing with conditional probability, it's based on conditions, one event occurring given that another event occurred. So in this case, for conditional events, the probability of A intersects B, as we would have indicated when we looked at the rules, is equal to the probability of A and B divided by the probability of B. Always note, whatever is, we say given that, whatever event has occurred, that is the event that would be placed in the denominator. The probability for that event would be placed in the denominator. So we will then go through some examples where we apply the rules of probability. So the first example we have, so it states an unbiased die is thrown. Find the probability that A, the score is even, B, the score is at least 2, C, the score is at most 2, and D, the score is exactly divisible by 3. Now, the first thing we would need to do is to define what our sample space is. Now, when we think about a die, if we toss a die, what are the possible outcomes? The die has 6 faces, and these faces are numbered 1, 2, 3, 4, 5, 6. So our sample space would therefore consist of the values 1, 2, 3, 4, 5, and 6. Now, looking at my sample space, what I would then need to do, and here we're applying the sample space method to determine the probabilities. So what I would then need to do, given each score, so for the first one, A, it says the score is even. So what I would need to do is to look at my sample space and look at the numbers that are even here. So looking at this, I have how many even numbers? I have 3 even numbers. So it's 2, 4, and 6. And these even numbers, so then the event occurring, so the event is that the score is even. So therefore, I have 3 even numbers, and I will then divide that by the sample space. So the probability that the score is even would be the number of even values from the sample space divided by the total number in the sample space. So that is 3 divided by 6, which gives me a half, which is 0.5. So there is the probability is 0.5, or there is a 50% chance that the score is even. Because remember, we stated that probabilities can be expressed as a percentage. For the second question, it states that the score is at least 2. Now, when it states at least 2, it means 2 is the lowest value. So it's either greater than or equal to 2. So we go back to the sample space again, and we look at all the numbers that are greater than or equal to 2. And as we can see, there are 5 numbers. Hence, the probability would be 5 divided by 6, which gives me 0.833. The part C of the question states that the score is at most 2. Now, if we're saying that the score is at most 2, it means 2 or less. So from the sample space, the scores that are 2 or less would be 2 values, 1 and 2. Hence, it becomes 2 divided by 6, which gives me 1/3, which is a probability of 0.33. And finally, it states that the score is exactly divisible by 3. Now, if we go back to the sample space, the numbers that are exactly divisible by 3 would be 3 and 6. Hence, the probability would be 2 divided by 6, which gives me a value of 0.33. Another example. Now, it states the result of a survey of 200 persons who purchased computers during the month of September is shown in the table below. So we have the various categories in terms of male and female, and also in terms of their ages, those who were under 20 years and those who were over 20 years. And we have a total of 200 persons who were surveyed. Now, the question states, if a person is chosen at random, what is the probability that the person is a female, the person is a female and under 20 years old, the person is a female or over 20 years old, and that the person is under 20 years old, given that the person is male. So let us go through the solution. So for the first question, it says the person is a female. So again, what we would need to do is to look at the total number of females. So if we look, there are 80 females. There's a total of 200 persons. Therefore, to find the probability that the person is female, it would be the total number of females, which is 80, divided by our sample or total sample, which is 200. Hence, the probability that the person is female is 80 divided by 200, which is equal to 0.4, or there's a 40%. The probability is 40% that the person selected is female. The second question then states the person is a female and under 20 years old. So if the person is a female and under 20 years old, so again, we look at the category. So we look at the category for under 20 years, and under 20 years, we would see that the female under 20 would be 60. Hence, it is 60 divided by the total, which is 200, which gives me a probability of 0.3, or 30% of the probability is a 30% chance that the female is under 20 years old. So going through part C, so we want to find the probability that the person is a female or over 20 years old. So we'll be using the general formula. The probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. So we would define A as the probability that the person is a female. So what we would do, we did that in part A. So the probability that the person is a female is 80 over 200. So that would be placed here. Then the probability over 20 years old. So what I would do is to look for all those who are over 20 years old. So as we can see here, the total number over 20 years old would be 60. Hence, the probability would be 60 over 200. Then we need to look at the probability that the person is a female and over 20 years. So what we would do is to look for the category over 20 years and female, and that would be 20. Hence, it is minus 20 over 200. So it becomes 80 divided by 200 plus 60 divided by 200 minus 20 divided by 200. And that gives us 120 divided by 200, which is a probability of 0.6. And finally, that the person is under 20 years old, given that the person is a male. Now, once we see given that in the question, so given that the person is a male, we want to find the probability that the person is under 20 years. So once it's given that, we know it's conditional probability. So we will use the conditional probability formula, the probability of A and B divided by the probability of B. So the probability that the person is under 20 years old and a male, so if we look here, there are 80 males who are under 20 years old. So it's 80 divided by 200 divided by the probability that the person is a male. So in terms of the total males, would be 120. So it becomes 80 over 200 divided by 120 over 200. Which gives us 80 over 200. Essentially, we didn't have to write it as such. We could just simply look at this and take the percentage, the ratio of males under 20 years divided by the total number of males, and that would give us the 0.667. So the third activity, so it says question 1 to 2 refers to the following table, which shows the number and brand of cars in 3 cities. So we have the brand of cars, Toyota, Nissan, and other, and the cities A, B, and C. So it says, what is the probability that a car selected at random from city B is a Nissan? And the second question, a car is randomly selected from among the 3 cities. What is the probability that it is from city C, but is neither a Toyota nor a Nissan? So we will take a break as you go through these questions, and we will return to go through the solutions.
You're watching Homeschool 101.
Welcome back. Hopefully you were able to complete the question in the time while we went on a break, so we will go through the solution. So for the first question, it states that what is the probability that a car selected at random from city B is a Nissan? So essentially, we're focusing on city B. So for city B, there are a total of 250 cars. So there were a total of 250. Then we need to say, what is the probability that it is a Nissan? So we will look at the total number of Nissan from city B. So from city B, there are 60 Nissans. Hence, it will be 60 divided by 250, which gives me a value of 0.24. Then I move to the second example, or the second question. So it states, so in this case, the correct answer would have been B, which is 0.24. For the second example, it says a car is randomly selected from among the 3 cities. What is the probability that it is from city C, but is neither a Toyota nor a Nissan? So what we will do is to look at city C. So from city C, we have, if it's not a Toyota nor a Nissan, then it must be other. And there are 30 such. So therefore, it would be 30 divided by the total number, which is 500, and that gives us a probability of 0.060. Hence, the correct answer is B. We will then look at probability trees. Now, a tree diagram or a probability tree, it allows us to see all the possible outcomes of an event and calculate their probability. Now, for example, a tree diagram for a coin that is tossed 3 times is shown here. So we know if we toss a coin, there are 2 options. We would simply get heads or tail. And because, so if there are only 2 options, which is head or tails, then the probability, the possible outcomes would be head or tail. So when we toss a coin once, there are 2 possible outcomes. Either we get a head or we get a tail. And because there are only 2 options, the probability of obtaining 1 head or a tail would be equal to 1/2 or 1/2. If we toss a coin a second time, then the options are also heads and tail because there are only 2 options. But when we look at the tree diagram, remember it states we're looking at all the possible outcomes. So if we toss it the first time, if we're looking at this portion of the tree, we're looking to say if the first toss we obtained a head, what are my chances of getting a head and the tail again? So I toss the coin again, my chances of getting a head is also a half, the chances of getting a tail is also a half. Down here, I'm looking at the option if my first coin toss, I obtain a tail, what is the probability of getting a head or a tail? So down here, this shows the options of getting heads or tails from the second toss. Now, as we can see, again, we have both options. So if we toss a coin a third time, these are also the possibilities, heads or tails. So essentially, if we're looking at the tree, the various outcomes, if we look along this branch, so the outcome would be head, head, head. So this is one option, H, H, H. Another option would be H, H, T. A third option would be H, 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 T, H. A fourth option would be H, T, T. Then if we looked at the second option down here, getting a tail, we could start by getting a tail, then a head, then another head. We could get a tail, head or tail. We could start by getting a tail, tail, heads, and then finally a tails, tails, tails. So if we toss a coin 3 times, there are 8 possible outcomes. The outcomes would be H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, and T, T, T. So these are all possible outcomes if I toss a coin 3 times. And basically what we would need to do in order to obtain the probabilities, what we would simply need to do is to multiply along the branches. So for example, if I wanted to find the probability of obtaining 3 heads, all I would need to do is to multiply the probabilities along the branches. So it would be a half times a half times a half, and that would give me 1/8. A key thing to note, a key feature also, if we look for each branch, if we take the sum of the probabilities on each branch, that gives us a value of 1. So the probability here, that gives me a value of 1. The probability here also gives me a value of 1. If we take the probability along all the branches, you should get a probability of 1. Note, so it says to calculate overall probabilities as indicated, we multiply along the branches and we add vertically, and the sum must be equal to 1. So I have an activity here. So question 1 to 2 refers to the information displayed in the probability tree diagram. It states that a jar consists of 6 black marbles. A jar consists of 4 black marbles and 6 red marbles. 2 marbles are drawn without replacement, and the tree diagram shows this information. Values not given are represented by X, Y, and Z. So it states what is the value of X, and the second question, what is the probability that both marbles are red? Go through, so look at the tree diagram. How would you find the value or the probability of X? And how would you find the probability that both marbles are red? Right, so we will go through. So for the first question, what is the probability of X? So what we would need to do is to use our knowledge which states that the sum of the probabilities on the branch is equal to 1. So therefore, if I have, looking at the first branch here, if the sum of this probability must be equal to 1, then to find what the probability of X is, all I would need to do is to subtract 0.6 from 1. So for this question, the correct answer would have been 0.40, which is A. So all I need to do is subtract 0.6 from 1 because the sum of the probabilities is equal to 1, and that would give me a value of 0.4. Then for the second question, it states what is the probability that both marbles are red? What we would have to do is to look along the branch where we have both marbles being red. So as we can see along here, both marbles are being red. So therefore, what we would need to do is to multiply the probabilities. So it will become 0.60 times 0.50, and that would give us a value of 0.336, so the correct answer would have been D. So this concludes our class for today. So just to recap, we would have looked at the applications of probability in everyday life. We defined probability. We distinguished among the terms experiment, outcome, event, and sample space. We looked at methods of assigning probability. We applied basic rules of probability. And finally, we explained the meaning of calculated probabilities. So I encourage you to go over your notes, go back through, review your notes and the activities on probability, and practice in preparation for the next class. All the best, and see you then.
You've been watching Homeschool 101, a partnership between ABS Television and the Ministry of Education. Thank you for viewing this lesson. Join us again next time.